Welcome to an intro to area between curves. So the general idea is if we have two curves, so for example, if we're just looking at a picture and we have some curve up above and then we have another curve down below that. We can focus on a specific region between two x values, and we're looking for essentially the area trapped in between those two curves. So the general idea here is sort of how do we go about finding this? We can use integration. We could look at, we could break this into little rectangles like with Riemann sums. And total up the area. Or we can use integration. So the basic rule is if f of x is greater than or equal to g of x on the interval, closed interval from a to b, then the area between the curves can be found by integrating the difference. So in other words, the area is equal to the integral from a to b of f of x minus g of x dx. Again, we can see that using rectangles. So if we draw our picture, if we have our f of x up top, g of x down below, then we are looking between a and b. We could break this up into a whole bunch of little rectangles. Of size delta x. And we could say use the right-hand side or the left-hand side, whichever one we wanted. We could do right-hand sides of each and just draw a bunch of rectangles where the height is the difference between the f and g at that right-hand side. And just add up all of these rectangles. Okay. So to do this, we would do our Riemann sum. We would be looking at the height essentially would be f of xi minus g of xi. Our width is delta x, and And so we would be looking at the area equaling the sum from I equals 1 to n of f of xi minus g of xi times delta x. But this is precisely the sum from I equals 1 to n of f of xi delta x minus the sum from I equals 1 to n of g of xi delta x. We're looking at an integral of f minus the integral of g, or the integral of f minus g. So using this rule, let's go ahead and find the area between f of x equals x and g of x equals x squared on the closed interval 1, 2. So let's go ahead and just start by drawing a picture. It is extremely important that we keep track of which function is on top. So this is to keep track of which function is on top. So if we draw our graph, f of x equaling x, we're just looking at the line y equals x. G of x equaling x squared. We're going to look at the parabola. It starts below f, but at x equals 1, it's going to cross and wind up above. So this is our g. So we were interested from 1, where they cross, to 2. So for the entire region between 1 and 2, g of x is on top. So note on the interval from 1 to 2, our g of x is greater than or equal to our f of x. So that means that when we go to do this integral, we are looking at the integral from x equals 1 to 2 of g of x minus f of x dx. So we do g of x first, since g is on top. So this is simply, this is our area equation. Our area is this definite integral from 1 to 2 of g of x minus f of x. So our area is the integral from 1 to 2 of x squared minus x dx. Otherwise known as, we would have 1/3 x cubed minus 1/2 x squared, evaluated at 1 and 2. We wind up with 1/3 times 2 cubed minus 1/2 times 2 squared, minus, in parentheses, 1/3 times 1 cubed minus 1/2 times 1 squared. This becomes 8/3 minus 2, and then we have minus 1/3 plus 1/2. This is 2/3 and then plus 1/6, better known as 5/6. So the area between our curves from 1 to 2 would be 5/6. So in the next video, we'll look at some cases where we're just looking at the area enclosed and they don't necessarily tell us the bounds. In the next video, we will find those bounds ourselves.